Our enzyme is catalase, and the reaction for it is 2H2O2 goes to 2H2O plus O2. This reaction is very important to the body because it breaks down toxic H2O2 into products that are non-toxic to the body. H2O2 is toxic because it's a very strong oxidizing agent, so it kills pretty much everything. The breaking down of hydrogen peroxide into water and oxygen is a catabolic reaction because it breaks down a more complex molecule into simpler ones.
So this right here is a visual representation of our reaction. We have two hydrogen peroxide molecules, so there's your oxygen and then hydrogens on each end, and they react to become a oxygen molecule, which is two oxygens bonded together in a gas form. And then there are two water molecules. So then this is our enzyme right here. This is catalase, which allows the hydrogen peroxide molecules to bond to its active site right here and then turn into these guys. Now this reaction is spontaneous under normal conditions, but it takes forever. So this enzyme allows us to go much more quickly by allowing hydrogen peroxide to bond in the proper orientation for the reaction to take place. This right here is a competitive inhibitor, so it looks a lot like hydrogen peroxide, but it is not. So it confuses the enzyme and it makes production a lot slower. This is a non-competitive inhibitor, so it doesn't take place in the active site, but it prevents the enzyme from being as productive as usual.
The reaction from hydrogen peroxide to water and oxygen through the use of catalase is an exergonic reaction because the products are in a more stable state than the reactants, so there's a release of free energy.
So under normal circumstances, our enzyme is able to take two hydrogen peroxide molecules in its active sites. And as you can see here, they're in the proper orientation for the reaction. If they're like this, the hydrogens would be touching each other, and that would be not favorable. So this allows the reaction to take place much more quickly. So the induced fit of this enzyme takes place when this alligator clip opens. It grabs down on the hydrogen peroxide molecule, and it changes the shape of the enzyme to fit this molecule. So through the magic of video editing, you can see that our two hydrogen peroxide molecules have turned into two water molecules and an oxygen molecule. So this reaction is now fully taking place thanks to the enzyme catalase, and these molecules can now come away. So we can open up the active site, and this can float away off into the distance. So now right here we have shown an example of a competitive inhibitor. This looks a lot like hydrogen peroxide, but it is not, so it fools the enzyme. So now this other hydrogen peroxide molecule, which the enzyme needs to react, cannot get in there because its spot is taken, and that's really awkward. So yeah, it has to float away, and this enzyme is now a waste of space. And now this is called a non-competitive inhibitor. It doesn't take space in the active site, but it goes into the top right here. So when the hydrogen peroxide comes in, the jaws of the active site are open and they remain open, so it can't clamp down hydrogen peroxide, and no reaction can be catalyzed by catalase.